We are going to be talking about the 2014 Calc BC FRQ number 5. Let R be the shaded region bounded by the graph of y equals x times e to the power of x squared, the line y equals negative 2x, and the vertical line x equals 1, as shown in the figure above. A. Find the area of R. B. Write but do not evaluate an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals negative 2. And C. Write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. Now we'll take it into three parts by first solving for A. Now to find the area, we must take the integral over an interval from a to b of the top function, which is x times e to the power of x squared, minus the bottom function, negative 2x. And our interval is from 0 to 1, and we replace these functions into the integral, and we can separate them and antiderive. First, focusing on x times e to the power of x squared, we could use u substitution for x squared and derive to get 2x dx. Now for u sub, we must change our bounds 0 and 1. But after plugging into x, we still get the same values from 0 to 1. We replace x squared with u, and replacing dx, we get 1 over 2x times du. Cancel out the x, and we simplify everything. And antiderivative of eu is still the same as eu. And replacing 1 and 0 into u, we get 1/2 times e minus 1. The second part is we have to get the antiderivative of 2x, which is x squared. Plugging in 1 and 0, we get 1. After finding those values, we add them all together, and we find e plus 1 over 2 after simplifying everything. This problem is worth 3 points, 1 point for the integral from 0 to 1, and anti-deriving the functions, and also 1 for the final answer. For part B, we need to write an integral expression that gives the volume of the solid generated when R is rotated about the horizontal line y equals negative 2. Now, we can set negative 2 equal to the function negative 2x. After we do that, we can get the point x equals 1. So now we have proven that the line y equals negative 2 crosses at this intersection of y equals negative 2x and the vertical line x equals 1. So we can draw the line y equals negative 2, and we also know that it's rotated. There's the top base, and here's the bottom base, and that is the exponential function. And we also need to recognize this line y equals negative 2x, which this part here is the shaded part. Now to find the volume, we need to write pi in front as the constant, because whenever we find the volume and then we're rotating, pi is the constant that is shown in a circular volume. So pi times the integral from 0 to 1 of x times ex squared, which is the outer function, minus negative 2, which is the line that we're rotating, squared, that is also the important part, minus negative 2x, which is the inner function, minus negative 2, the line, squared. And we simplify everything, that will be our answer. This problem is also worth 3 points, writing 2 points for the integrands from 0 to 1, 1 point for the limits, that's the interval, and the constant pi. For C, write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. Now, a helpful way to find the lengths of the sides is by finding the intersections, the intersecting points. Now we know that this vertical line is equal to 1. Now we just need to find their y values. From part B, we know that we drew a line across y equals negative 2, so we can say that intersecting point is 1, negative 2. And if we plug in 1 into the exponential function, then we get 1. So then that we get e as the y value. Now, with that, we can find the length of the line x equals 1 to get e plus 2. Now we are finding distance. Since that there is no negative distance, we are considering absolute values, so e plus 2. Now to find the length of the line y equals negative 2x, we can treat this as a hypotenuse of a triangle using the Pythagorean theorem. Replacing 1 with a and negative 2 with b, we can find the value c, which we would get square root of 5. Now to find the length of the exponential function, we can use the arc length formula, which is the integral from a to b of the square root of 1 plus dy dx squared. Now to find dy dx, we must use the function that we need to find to get the distance, which is x times e to the power of x squared. And after deriving, we get e to the power of x squared times 1 plus 2x squared. And plug that back into dy dx, and we get the integral from 0 to 1 of the square root of 1 plus ex squared times 1 plus 2x squared squared. Now we found the distances for all sides of our area R. Then we can find the perimeter, write the expression but do not evaluate, which would be the integral from 0 to 1 of the square root of 1 plus ex squared times 1 plus x squared squared plus e plus 2 plus square root of 5. This problem is also worth 3 points, recognizing that we must derive the function that we need to find for the arc length, and then 1 point for the integral from 0 to 1, and then 1 point for the final answer.